morning. So this is assignment number 3 project of concepts in programming languages, and in this project the project deals with heap management system. So here we have to implement heap management scheme, implementing allocate and deallocate functions, ensuring that the adjacent free blocks are merged together. So the heap management scheme used here is Fibonacci heap dynamic pool adjustment. And to reduce the cost of allocation, separate free lists of blocks of different sizes which are Fibonacci numbers is maintained, and each request is rounded up to its next standard size. Standard size refers here to next standard Fibonacci number, and a dynamic division is used, which means that we will give a smallest possible block for a given request. So if we have a block greater than that request, the block will be divided into two parts. Let's say previous Fibonacci number, that is fn minus 1, and previous to previous Fibonacci number, that is fn minus 2. And we will then decide that, for example, if this is capable of that request and this is equal to that demand, that is which we calculated by here, that next standard size. So we will give it for that demand. If the smallest one is equal to that demand, we will give the smallest one. But else, if both are greater than that demand, then we will look for the smallest block and we will divide that smallest block again, and this will go on recursively till that point we don't get that demand. Else, if we don't get this block fn or any block greater than that, we will say that uh, that our size is full now. So in this way we are giving smallest block to allocation. So the algorithm for allocation is that request is checked first, and it is constraints are checked, that is if request equal to 0 or it is less than, that is if it is less than 0 or minus 1 value, then it is returned and says that the request is invalid. After that, the demand, that is demand means the rounded up value of that request. So a index is calculated by demand. That is index means in our Fibonacci numbers, here we are using there as 1, 2, 3, 5, 8 in this way. So so at which index the demand Fibonacci number comes, that is our index. And if that free list of that index is empty, then next index is search. Else that block in that index is given and block is removed from free list. So if demand is equal to block size, then we will give that block. Else if demand is equal to previous block size, that the same thing that I have discussed here is the it is written here. And constraint are also checked here, that if not found biggest block of demand, we will print message and say that null returned, negative and zero request not allowed. So in this way we are implementing it with corner condition, that is a block of 2 and we have demand of 1. So we have to divide it 1 and 1, but both will go into free list array of 0, that is 0th index, because both are of size 1. But whereas our general scheme is that we will previous will go index minus 1 position and previous to previous will go index minus 2 position. So this is corner condition that we have to implement in our algorithm. Then there is in doing this algorithm, that free list should be updated, and lastly filled list also. Yes. So requirement is that list of free list, that is array of free list of standard size blocks, that is Fibonacci blocks. Then there is Fibo list, that is uh, the list of Fibonacci numbers. Then there should be this free list array, that is array of free list, and means array of free list blocks, means here block contains list, and then filled list array, that is array of blocks which are array of list which are free, it will contain the addresses. And after that, in our Fibonacci numbers, they will start from 1 2 3 5 8, not 0 and 1, because 0 request is not available, and 0 is not valid. And if we take 1 twice, then because both are blocks of size 1, so here only one block is used. Now deallocation. So in this way we are doing allocation, and this allocation is giving the smallest possible block, and also changing free list as well as filled list. So in deallocation, the algorithm is that requirement is that we will give the we will free that block, and we will merge, and merge in that way that we will have a biggest possible block that can be merged, so that in future if there is bigger request, we could satisfy that. Then algorithm for it is that take that address of block is taken, which is have to remove. Then it is searched in free list, because here we don't know the size of that block, because we don't have maintained that table that this variable has this size. So we will search that address directly into field list array, and then if not found, we will print a message that there is an error. And if found, so if found the index, and it is not going to happen because we are doing like free var, so var is storing some value. So so now, so this not found is not going to happen, but it is a precautionary step that is taken here. And if found, we will store that index, then we will remove address from free list of index, that is deallocation is done here. And now all that we have to do is to have a merge algorithm. So we are checking now that is previous address is free, that index is not equal to 0, and if previous address is free, so if it is free, then we are appending the address, this address that is given address to free list of index, because this will help in our merge function. And then we are doing field address equal to previous address, and because this is the starting address of that block, so this is done here. Then we are removing that previous address from index -1, and then we are merging the next block if available using merge block function. After that, in else if index is 0 and next address is present in field list of 0, so here that is index is 0 and next address is present in field list of array of 0, because it is possible, because 2 can be there, because there will be size 1 and 1. So we will remove the next address from field list of array of 0, index 0, and then we will again call a merge next function for index plus 1 now, that is 1. And if previous address is present, the same will be done here. Only the change is that the address will be equal to previous address, and same merge call function will be there. And else, that is previous is also not there and index is also not equal to 0, then we will call merge block function for that index. So the natural question is now is that what does this merge function do? So if found the address in the next blocks, this merge function merges them. That is, it merges all the next blocks in which the address is found. And if previous address is also present, and if it is free, it does merging too. And this is the case which can happen when we have more number of variables. That previous address we have checked here also, but a previous address may also remain after doing this also. So this precautionary step is taken in this merge function. So if previous address is present in index -1 field list of array, so address is now previous address, because block will start from here. We will remove previous address from that index, and we will change the value of index to index -1, because our block will start from this index now. So means merge function should be from now index -1 function. And if index plus 1 is less than size, that is taking the constraint into consideration. And then if we found that next address, that if we found that next address in field list of array, in index minus 1, that if it is present, then we will remove next address from that index, and we will call next blocks function for index plus 2. Else we will append that address. Here next address is calculated by using the formula, like we add Fibonacci list of index to our address and subtract, and previous address by subtracting Fibonacci list of index minus 1. So let us see how it is implemented in our program. So firstly, we will require a list class. So this gives the definition of list class. So here this item type int type def is done. Then a node tag, this node is containing data as well as the next pointer to that node tag. Then there is class list. Here private is LPTR, so that our LPTR should not be accessible to to accept friend and member functions to another function. So here list, this is constructor, then destructor, then append member function is there, which will append this j into this list. Then remove function is there, which will remove this j from this list. Then operator equal to, which will check if it is equal to that list. Then operator equal to, which will is assignment operator, which will assign list with this L1, and then which will copy all the contents from this to L1. Then there is a index method, which will give the index where this j atom is found. Then there is a friend function that is useful for doing cout, and there is a size which will tell the number of elements in that list. Then there is this array helper function, that is this square bracket function, which will help in getting that, for example, array of 1 equal to or list of 1 we can do from here, so that searching will be efficient quite. So let's see its implementation in list.cpp. So implementation of it uses various functions, like let's see firstly, these are basic functions of the delete list. These are general for any LPTR, and insert at end, and delete value. Delete value is deleting value from that LPTR, and managing that all these things are managed here, and linking etc. is managed in this function. These are general functions. And display list, for giving some good display to our list. I have done this giving angular brackets, and then doing this thing comma to separate them, and again doing a square bracket, so that now a list is starting from here and ending from here, to give a better visual understanding of our list. Then this k value function, that is, it gives the kth value which will useful in indexing. Then there is lp constructor, which uh, makes lptr to null. Then there is destructor, which will delete the list and make lptr to null. There is append function, which will insert and end this j comma lptr. There is remove, which will delete value from lptr, this j value. Then there is operator, which will display list after doing cout. And then there is a equal to operator, that is, if it is equal to, then it will directly provide that star this, that is this object, this reference to this object only. And if otherwise, it will delete list firstly, then it will do lptr equal to null, and then from a new starting will be done here, and all this appending will be done of nptr arrow data, that is the arrow. This will be done nptr equal to l dot lptr. So these are some simple functions. Then operator equal to, which will check that if both size is same, then it will be going forward, and it will check that if every value is same, it will return yes, they are equal to, else it will true, else it will give false. Then the size function is that while lptr equal not equal to null, then I do I plus plus and return I. Then indexing function is there, that it will check when this the first it occurs, then the retrieval will be equal to 1, or by default it will be -1 if not found. So after that, there will be this operator, this function which will return the k value, that is the function that we have seen. Then after that, the reference will be written here also, so that left side that assignment should be done here. Then we want free list array. So for that, array of list class is made, which will have a size and list. So here there will be a constructor, destructor, then this operator, and then there will be a cout for that. Then make space, that is making a new means this array equal to new, then a list of n. So for doing that, make space, then int index is there, so it will give the answer that where it occurred. Then there is a len function which will provide that what is the size of that array, and just it returns the size. And then there is a print function which will print that array. So let's now check list array.cpp, and here uh, this array is given null value and size is given 0 value here. Then they are initialized to null and 0 respectively. Then there is a destructor which is removing that address, that array, complete array is deleted here, and array equal to null and size equal to 0. Then there is operator which is returning array of j. Here it is simple because we are directly using array. After that, here it is referring to this our list, individual list, because this is the array of lists. So assignment is possible here because referencing return is done. Then there is c, for this cout we are doing like this, that a dot arr is sent, and print function is called here. So here there is print function. So len is Fibonacci list of size, because in our program this Fibonacci list is up to our requirement, and all will be same. This number of blocks will be same also. So here it is made here, and we can do like here also, that that here we can for getting side we are doing this. And after that, there is a make space, that is array equal to new list, and n, that is make space for this number of list, and size equal to n, size is updated here. Then we are doing len, that is returning size. Then there is index, that it checks whether this is equal to that. For means in the array, in the individual list, if there is a this j present, then it will return that index of array. And so for that, this function is there, and this is made. These are simple functions which are very helpful in our program. After that, let's check now driver.cpp. So here we are making this list, empty list, which are means throughout our program they will be there. Then array of list, and list, array of Fibonacci list, then array of list, field list of array. Then in general.h, in our now general.h, we have made here this we have made extern, because we are referring to another object which are defined in driver.cpp. So we have made them as a extern. And then after doing that, there are quite functions like near big fib, near fib, populate free list, populate field list. And then there is a print which is defined here, which, because it was not defined in list array.h, so it is defined here. And after that, let's see now what driver.cpp does. So firstly, it welcomes us to a simulation of heap management program. Then it demands us the actual size, so we give the size, that is so now heap size should be given, because we are dealing with Fibonacci numbers. So a heap size is given to it, which is standard heap size, and this is done by this near big fib function. So let's see what is there in that function. So here, so this is now a function. So it is taking size as its argument, and then ritual is there, and this stuff is about making a Fibonacci numbers, and in doing so it is appending Fibonacci with k, that is it is appending that k value, that is firstly 0, not 0, firstly 1, then 2, then 3, then 5, etc., up to that n, that we demand that less than equal to n. So up to that this is appended, and prev is written because k is make greater than here, so that the loop will end, and prev is assigned k here, so prev is returned. So in this way, this big fib function also populates our fib list as well as gives us the nearest, the smallest or equal to our actual size of memory. So in this way, this is done. Then we are doing populate free list. So let's see what is in populate free list function. So in populate free list, this len equal to Fibonacci list of size, that is our size member function will give the size, and we are, as we are appending, the size is also changing. So size will be given to it. Then we are making space in free list array by using our make space function, that is it will give new list, and len, that is len number of list will be allocated on heap, and then int I, for I equal to that less than n and I plus plus, we are making equal to empty list. So here empty list is nothing but that is LPTR equal to null, because we are only defining it. So this will be given to this, and in len minus 1 we are appending 0 to it, that is we are giving 0 because uh, this len minus 1 starting will be having the largest possible block of that Fibo list of index len minus 1. So it will start from 0 and it will end from that Fibo list of index len minus 1 minus 1. So this will be the address range of that, so it will start from 0. So 0 is appended here. After that, in driver.cpp, we are doing populate field list. So what is there in populate field list? So here there is nothing but we are just doing the same thing, and we are just giving empty field, empty list, because nobody is filled initially. So after that, let's now see this, that if we do like this, that we are giving that where equal to malloc 1 we are doing. So what is there in malloc 1? So for that we have to check this allocate dot h and allocate dot cpp. Allocate dot cpp. So here in allocate dot h there is this function, that is this malloc function. So let's see what is in that malloc function. So here malloc function, yes. So here is malloc function. It allocates space for a given request on heap, means here virtual heap, and returns the address of the allocated block, and otherwise it returns null here with a value -1. So it will check firstly uh, the request, and if allocate request will be done, and if var equal to -1, that is it is not allocated, so it will return null, means it will print that message return null, and this -1 will be given out. Then after that, let's see what is in allocate function. So here is allocate function. It is taking request. So if it is r is less than equal to 0, it is saying that it is invalid request. Or if r is greater than Fibo list of size -1, so it is saying that insufficient memory, because these are pre-checking which are done. It may happen that when we enter our program and we find that the allocation is such that the nobody block is giving us that result. uh, it is less than heap size, but we are not getting that result. It is also possible, but these are some precautionary steps that are taken so that we will not go inside our program. So then demand is equal to near fib of this r comma this string is given, that is greater than equal to. So this is the overloaded function basically, that near fib. So let's see that this is defined in heap manager.cpp. So here this near Fib function is there, which is overloaded with this sign. The same mechanism of generating Fibonacci number is there, and then if it is greater than equal to, then if it is equal to n, then prev is written, else k is written. If greater than sign is there, then k is written. If less than sign is there, p prev is written. So this is a simple function which is here, and which is used here. Then in that allocate, this is used. Then demand means we are getting now demand. What is our demand? Then index is checked that the Fibonacci list of index. What is the index? At which index it occurs in Fibonacci list? Then retrieval is done here, which equal to allocate helper function is called. And now let's see what is in allocate helper. So here retrieval is initialized to -1. Then it is checked that field list of array is equal to empty. That is, we don't have a block of this demand. So we will do allocate helper and demand index plus 1 comma true. This is overloaded with false value. So true means that we are check here, but it is empty. So after doing that, it will go here and index plus 1 demand. So else now else part will be done. If repeated equal to false, that means we have that it is not empty list. We will satisfy demand. So let's see firstly satisfy demand function. So it is a very simple function which returns gets retrieval equal to address of that block, and then it appends that address to field list and remove that address from that index from field free list array. So in this way, this is done, and a message is printed that we have allocated the successfully. So this is satisfy request function, and else arrange is done here, which arranges the block. uh, Else means arrange function means other thing is managed by this arrange function now. So if here index plus 1 is done and it is false, it is true, then arrange function will manage now. So let's see arrange function. What it does is that it will have this retrieval equal to -1. Fib1 is Fibonacci list of index -1, and if index -1 equal to 0, that is the special case is managed here. Then demand equal to 1, then this both are appended, that is fib1 and fib2, that is previous and previous to previous. Else this fib2 equal to index -2, it is that previous to previous, and it is appended to index, that index -2. This here address is given, that starting address, and index -1 is given the starting address plus fib2. That is a bigger block in index -1 and smaller block in index -2. And then the block is removed, that index 0, that's address block is removed from index, and it is taken that fib1 equal to demand, then satisfy demand from index -1, because fib1 block size in index -1, fib2 block size in index -2. So satisfy demand. And else the retrieval means both are greater than it, then we are doing demand for index -2. That is, we are again splitting the block of fib2, that is smaller block, so that we are possible to give a smallest block possible. So in this way, nicely this allocate function is doing the work of giving smallest block. So let's now check the deallocate the in driver.cpp. So here let's the malloc is done, and then the change free list and field list is printed. And now let's see that if that free list is done here. Suppose that we are doing now free of var1. So how it will be there? So free function. So they are defined in this deallocate.h. So here there is a definition of them, and now check. Let us check that free function. That what does it does? This free function is there. It takes index as a address of as an argument and calls deallocate address function. So here in this function, index same index is taken from field list array, that is it present or not, and we know that index member function of field list array. Then address is removed from there. If index equal to -1, it is said that it is out of range, and means it is not found. So this is there. Else this else part is done, and so in this else part, if index is not equal to 0 and previous address is there, which is done from this searching list. So index minus 1 and free list of index minus 1, this address is present in this list, that is in index minus 1. Then we are doing appending that address to index, which is for useful for merge function, and then we are reducing our address to previous address, and then we are doing remove that address from index minus 1, and then we are calling merge block function for index minus 1, uh, because from there now it will start. And let's see if index equal to 0, and here address minus 1, which means previous address is present in our 0th block in field list array. So address is decremented by 1, then it is removed from there. Then merge block function is there, which is 1 comma address is done, means merge block function for index plus 1, that is 1, and address is called. Else if next address is present, then the next address is removed and 1 comma address is called, because here address equal to address plus 1 is not required, because block is already starting from address. Else this merge block function is required. So basically our merging is mostly done in this merge block function. So it is firstly check that index is not equal to 0 and if previous address is present or not. And if the j is not there in that index, then append j is there, j equal to j minus Fibonacci list is done, and then pre list that j is removed from there, and index equal to index minus 1 done, is done here. After that, if address equal to j, that here we are what we are referring to j is that address. So the address is changed and updated here. Then address addr equal to address, that is here we are using addr term, and next address is defined by this n addr. So if index plus 1 is less than size of our array, free list array, and if it is searched that n addr is there, then what we are doing, we are removing that NADDR, and then we are merging blocks for index plus 2 comma address. That is, it may happen that it may present in another block also. So we are getting a biggest size block. Else what we are doing is that we are appending that address, that it is not next address is also not found, or this index is become full, or index plus 1 equal to that uh, array of length. So this is a condition that is checked here. So here it should be actually the free list of array of length, and there it should be minus 1, because we are checking here the constraint should be checked properly, so that uh, when it is index plus 1, so we are checking in, yeah, length minus 1, so it should be minus 1 here. And because because this is a large last block that can be possible, and if it is not minus 1, then a block of free list of index minus 1 can go here, and here it will search in the out of range block. So this is done here, and in this way deallocation has happened and merging is done here. So in this way this is done. Now let us check a demo of this program. So here, um, in this our demonstration, we are doing int var equal to malloc 1, that is the allocating size of 1, and then after doing we are printing this message that what is stored in variable, and then we are printing free list array, field list array also. After doing that, we are freeing that var, our variable, and after doing this is a simple firstly, and checking that that arrange function and allocate and deallocate happens nicely or not. Then so let us check now. So expanding this screen, doing, let's clean all that, and let's now from new. So now let's do our, let's clean this also, clear. So let's now final.exe. So let's we have, let's say size of actually is 100, and our program will have heap size of 89. Here printing mistake has there, and it is 0, that is 1, 3, 5, 8, 13, 21, 34, 1, then 2, 3, 5, 8, then 13, 21, 34, 55, and 89. 89 block. Then variable equal to 0. So check, we can see that here this 0 has come here, 1. Then means proper splitting has happened. And after doing this malloc 1, this variable equal to this we have done here, this also, that variable 1 equal to malloc 1. And then here this 1 has come here, and after doing freeware 1, this 1 has gone here, that is same condition has happened. And after doing freeware, this 0 has gone here, 0 and 1 will have a block of 2, so it will come here. This 1 and 2 will have 1 and this 2 and 3 will have block of 5, so here they will go here, and this will go here, this and this will here, and after here and here 0 will be there. So this is working finely. Now let's check our again. Now let's make our in driver code. Let's make some changes, like let us do now that this heap size is there. And so a change made here is that same variable equal to malloc 1 and var1 equal to malloc 1, and the change is that we are freeing var first, that is 0th address we are freeing first, and then we will free it one address. So it will have to check previous also, that is 0, and then combine it all also. So let's check does it give our result. So as we have changed driver.o, it has done here. Then doing final.exe. Let's maximize this, and let's give again 100, let's say. Then doing this, so we can see that same has occurred here also, that 0, 1, and we are as freeing var firstly, so 0 will go there, and then var 1, so 1 will go there, and they will come here, that it will check previous is there or not, and it has happened successfully. So let's clear it, and again check another that let me make some changes in driver code. So the change that we have made here is that we are again allocating a variable 2 with the size 22, and after doing that we are firstly giving 0, then 1, and as it will be allocated, this will not go till complete, and then we are deallocating this var2, that is this block of 20, this request of 22. And let's check now what happens here. Saving this and doing again. Let's maximize it, and then yes, so let's give again 100. So you have hit skip size of 89, then it has done here successfully, then it has also allocated this successfully with giving 55 as our that 34 block will be allocated to this, because 20, after 21 it has come. So let's check, so let me do some this. So we can see that now by doing var 0, var free var, so 0 will come here. After doing free var 1, this will combine with this will combine with this will combine with 13, and they will overtake this 34 and will go here. And now we will know that why we in merge function we take another condition that previous is there or not, because it will come here, it will check that yes previous is there, and here there will be 34, but we should check again that if previous is present, that is this 0 is also previous, and here it is not previous, but after doing that merging, there is previous. So this for this checking this merge function, one part of code is there which check previous also. So after it will check previous, and the 0 will be there, and they will come here, and this for this block there will be 89 block. So after doing all this pre management, this is giving 0. So this code is working finely now. So So now doing again clear, let me give some arbitrary output now. Let's see, giving, let's now I will make this let me. So here the change that I have made is that commented all these things, and now let's give arbitrary that int var equal to this equal to 10 43 3, and now not making any free list or doing anything, just see out free list at last, that is check if it is that 0 has come to end or not. So let's doing this means we are just taking now that what is the final output of it, and let's now it will come. So let's give 100. So let me maximize the scheme. So these four variables, four requests, four successfully allocated. This is initial condition, and this is the final condition of our free list. So in this way, we can see that after doing all these pre businesses, we are getting the free list, uh, which is which is actually that we wanted, that all the blocks are freed and we get the complete heap size. So this proves that this algorithm is working, and it is merging also it is allocating, and it is merging these previous blocks as well as next blocks, and it is giving the maximum size. So thank you, and have, have a nice day. Thank you.